talking about the graphs of sine, cosine, and tangent. So the first thing we're going to do is actually draw a graph of sine of x. Now in the past, recall that we've normally been writing sine with the angle theta. So what we're going to do when graphing it as a function of x is we're actually going to, instead of theta, we're going to be using x. So any angle theta on the unit circle is actually going to be treated as our x value when we draw the graph in the xy plane. So if we are going to sketch a graph of sine of x, the first thing we can do is try to come up with a few exact values. Now recall on the unit circle, that each point has an x and a y, and remember that the x value is cosine and the y value is sine. So the point here, corresponding to an angle of 0, is a point 1, 0. And so remember that the x coordinate is the cosine and the y coordinate is the sine. So if we're focusing on graphing sine of x, we're going to be focusing on that second coordinate. Now, recall if you rotate your angle up to pi over 2, the coordinates here, 0, 1. If you rotate all the way over to pi, coordinates of this point, the x is -1, y is 0. And if you rotate down to here, which is halfway between pi and pi over 2, that's 3 pi over 2. The coordinates of this point, the x is 0, the y is -1. Finally, if you end up rotating all the way around to 2 pi, then you're back where you started with a cosine of theta equaling 1 and sine of theta equaling 0. So using this unit circle to pick up a few exact values, you can see that the sine of the angle 0, which is right here, is just 0. If you're looking for the sine of another angle, such as pi over 2, well, that's right here. And of course, the sine is the y value, which is 1. Sine of a half rotation of the unit circle is corresponding to a rotation of pi, which has a sine of 0. Next, sine of 3 pi over 2 has a value of, as you can see, -1. That's right here. And finally, if you rotate all the way around to 2 pi, you're back to the beginning. Sine of 0 is equal to 0. And of course, if you did more rotations of the unit circle, you would just get the same values for sine. Alright, so now that we've picked up those exact values on the unit circle, then what we can do is we can try to graph y equals sine of x on the xy plane. So again, this is what we're graphing. So we'll draw our xy plane. Now we're considering the stuff that we're feeding into the function as x values, and our output are the y values. So sine of 0 equals 0. This corresponds to the point 0, 0. Sine of pi over 2 equals 1. That's a x equals pi over 2, corresponding y value of 1. So at pi over 2, we're up at 1, and we have another point. Now when we're at pi, we are actually back to 0. We'll also graph 3 pi over 2, and then we'll stop at 2 pi. So when we're at 3 pi over 2, the point actually, so when we're here, the point actually drops down to -1. And then when we're at when we're at 2 pi, when we're at 2 pi, I think I meant to write 2 pi here. Let me fix that. Recall that when you've done a complete rotation of the unit circle, 2 pi, then you get a sine of 2 pi equals 0. So at 2 pi, we're actually back to 0. So what happens is, if you draw the curve, it actually looks pretty much like this. Do a little better so I actually go through the point. There we go. So it looks like that. And that's a complete period, a complete rotation of the graph of y equals sine of x. Now remember, as you rotate around the unit circle, you're just going to keep getting the same values. So if you wanted to keep drawing this picture, it actually just keeps repeating like that, keeps going. In both directions. But the main period of sine of x is this. And the length of the period, a complete cycle, if you will, of the function, is 2 pi. Now notice that as you go on the unit circle, the biggest sine can be is 1, and the smallest sine can be is -1. So that can tell you the range of the y values that are allowed. In terms of the range of the x values allowed, notice you can do all real numbers there. So just to discuss a few properties of the sine function, again, the domain, remember what domain is. Domain is all allowable x values. That are allowed in a particular function. So here the domain is -infinity to infinity, which is the same thing as all real numbers. The range of a function, this is for any function, are all possible y values. Well, for here, the y values that are allowable, the smallest it can be is -1, and the largest it can be is 1. So you can write that in interval notation as -1 to 1 in square brackets. The sine function is periodic in the sense that it has that repetitive aspect, and remember that the length of the period is 2 pi. So what happens is, even if you have an extra rotation of the circle, the sine value is going to be the same. So for example, remember that the sine value of the angle 0 was just 0, but that's also the same as the sine value of 2 pi. Now, if you do need to draw a quick graph of sine of x, a good way to do it is just to remember what it looks like, the general shape. Sine looks basically like this. And the period is 2 pi. So if you needed to graph just one period of it, there it is. If you needed to graph the whole entire function, then you can do your repetition from there. Okay? The next graph we're going to talk about is cosine of x. So what we're going to do is, just like last time, we're going to start off by considering the unit circle, because that's the only way to get exact values of cosine of x for various angles. Couple key points. Remember, this is 1, 0. This is 0, 1. This has an x value of -1, a y value of 0. And here we've got an x of 0 and a y of -1. But the difference here, remember, is that this time we're actually looking for the cosine, not the sine. So if we're looking for the cosine, we're going to be looking at the first coordinate, because remember how it goes. It's cosine, sine. Okay, so first let's consider an angle of 0. That's where you're in standard position and you don't rotate anywhere. You just are at an angle of 0 radians. So what we're going to do is, we are looking for cosine here. So we're going to look at cosine of 0. Cosine of 0 is equal to, well, you just look over here, get the value 1. Next, just pick another angle. I think it would probably be easiest to just go ahead and use the angle pi over 2. So if you look at an angle of pi over 2, the cosine value is the x value again of the point, and it's 0. So cosine of pi over 2 is actually just equal to 0. Now, what we can do is we can look at the cosine of the angle pi, which is the half rotation of the unit circle. So if we're at pi, the cosine is equal to -1. If you actually rotate down to 3 pi over 2, then the cosine is going to be 0 again. And lastly, if you do a complete rotation of the unit circle up to 2 pi, we're back to where we started. So cosine of 2 pi is just back to 1. At that point, we've done a complete rotation of the unit circle, so we've completed a complete period of the graph of cosine of x. So just erasing here the unit circle, so we can go ahead and write our graph on the xy plane. All right, here we go. So the exact values that we're considering, remember how it works. We're going to treat the input of the function like the x and the output like the y. So we're really looking at x values of 0, pi over 2, pi, 3 pi over 2, and 2 pi. All right, so let's draw the graph. So cosine of 0 has a y value of 1. There's the point. Cosine of pi over 2 has a y value of 0, right there. Cosine of pi has a y value of -1. Cosine of 3 pi over 2 has a y value of 0, And cosine of 2 pi sends you right back up to 1. So cosine of x actually looks like this. And it does have a period length of 2 pi as well, just like sine of x. So this is a graph of a single period of cosine of x. Of course, if you needed to plot any exact values, you could just pick any of these. Here we have x is 0, y is 1. Here we have x is pi over 2, y is 0. Here we have x is pi, y is negative 1. So that's how you can pick up exact values and plot them. This is the point 3 pi over 2, comma 0. And this is the point right here. X is 2 pi, y is 1. Now, as you do more rotations of the unit circle, there's going to be a repetitive nature to this. So cosine of x is going to keep going in both directions, just like this. So this is what a graph of cosine of x looks like. Now, if you wanted to draw a graph of cosine of x in your calculator, you can do that, but just be careful because it doesn't give exact values. So, what you could do if you wanted to graph this is go to your y equals menu on your calculator. Graph sine and cosine. Here's sine right here. Here's cosine right here. So if I wanted to graph sine, I would just type in sine of, and then press the variable button right there, and then ask the calculator to graph it. Looks like this. Of course, I could adjust the window a little bit if I wanted to get a better view. How about instead of going from negative 10 to 10, or let's change the y values. How about instead of going from negative 10 to 10, let's change it from, say, negative 2 to 2. We know it only goes up to 1, but this will give us a little space to see it. You could also zoom in. That would work as well. So if we're talking about y equals sine of x, then if we do a complete period of the y equals sine of x, it's right here. So this is going from 0 to 2 pi. Now, if you wanted to draw a graph of cosine x as well, what you could do is go back to your y equals menu, clear it out, change it to cosine of your variable, graph, then what's going on here? Well, the basic part of the one period of a cosine of x is from here up to here. So we've got y equals cosine of x, and again, a single period goes from here up to here. This right here is the point pi over 2, so we're going from 0 to pi over 2, which is a complete period of cosine of x. Now, if you'd like to see both of these on the same graph, all you've got to do is just put them both into your y equals menu. So put in sine of x and also cosine of x. And then just press graph. So what we've drawn here, y equals cosine of x, is in the blue. Y equals sine of x is in the blue. And in the red is y equals cosine of x. And as you can see, they're actually very similar, just shifted. One quick tip, if you're having any trouble with the calculator in terms of trig, remember you've got to always have your calculator in the correct mode. So if you press the mode, notice how you have an option here between radians and degrees. So just make sure that if you're intending to be in radian mode, that you have radians selected. Okay. Now, again, with the cosine function, it has a lot of the same properties as sine. It also is periodic and has a period length of 2 pi, as we've already discussed. The domain is all real numbers. All x values are allowed. But the range, we only have values. The lowest it can be is -1. The biggest it can be is 1. All right, the next thing I'd like to show you how to graph tangent of x. Graphing tangent of x. We're going to start with looking at exact values on the unit circle, just like we did with sine x and cosine x. So first, looking at the unit circle. And then just trying to pick out a few interesting values. Well, first, if you look at the angle of 0, the coordinates 1, 0. Now remember, the first coordinate is cosine, second coordinate is sine. So we're not going to be able to immediately get the tangent from this picture. We've got to actually calculate it each time. So tangent of, say, the angle 0, just no rotation at all. Now recall that tangent of x equals sine of x over cosine of x. So tangent of 0 is going to be the same as sine over cosine. And sine of the angle 0 is 0. Cosine of the angle 0 is 1. So tangent of 0 is equal to 0. Next, how about we do pi over 4? So if we rotate up to pi over 4, recall, if you're looking at the unit circle, the coordinates of the points corresponding to pi over 4 are, well, just to jog your memory, we'll look at the unit circle here. Unit circle for pi over 4 is square root of 2 over 2, comma, square root of 2 over 2. So for the square root of 2 over 2, comma, square root of 2 over 2, oops, that is corresponding to an angle of pi over 4. So recall that we already calculated that tangent of 0 is just 0. And now we're seeing tangent of pi over 4. Well, notice that it's going to be sine over cosine, but that's just going to be square root of 2 over 2 over square root of 2 over 2, which is just going to give us a value of 1. As another example, consider what happens when you rotate up to pi over 2. So if you happen to be at pi over 2 here, the coordinates of the point, well, x is 0, y is 1 on the unit circle. So what that means here in terms of tangent, if you're looking at tangent of pi over 2, well, remember, tangent is sine over cosine. The sine of pi over 2 is 1, and the cosine of pi over 2 is 0. So what's happened here is, oops, that's an indeterminate form. So what happens is if you're trying to take tangent of pi over 2, it's going to be undefined. So we won't be able to draw a picture at that point. Now, what's going to actually happen there is there's going to be a vertical asymptote. Let's see if we can get at least one more point to plot. How about we go ahead and rotate to 3 pi over 4, perhaps? So rotating all the way over here. This is the angle 3 pi over 4. And the coordinates of the point here are the same as they would have been for pi over 4. Except that the x value is negative. So this is negative square root of 2 over 2, comma, square root of 2 over 2 for this point right here. So that means that if you're going to try and take a tangent of 3 pi over 4, then what you're going to do is you're going to get the sine divided by the cosine. This is square root of 2 over 2 divided by negative square root of 2 over 2. In this case, you get a value of negative 1. Okay, so let's go ahead and try to draw a graph on the xy plane. All right. So remember, I'm just writing this back in so that it's a little bit smaller. We calculated this to be 0, this was 1, this was undefined, this turned out to be negative 1. So the points that we've looked at so far, we've got tangent of 0 equals 0. We've also looked at pi over 4. We considered pi over 2, 3 pi over 4. We could do pi as well. If you wanted to look at pi as well, well, recall that tangent of pi, well, tangent's always sine over cosine. The sine, if you're all the way over at the angle pi, is 0, and the cosine is -1. So tangent of pi is just going to be 0. Now we have several points to look at. Now remember that pi over 2 is undefined, so there is going to be a vertical asymptote there. So we'll just draw a dotted line to denote that that's not going to be part of our function. Now tangent of 0 is 0. Tangent of pi over 4 is at 1. Tangent at 3 pi over 4 is down at -1. Tangent of pi is back at 0. Well, what happens is, if you also looked at negative pi over 2, you'd also get an undefined value. It goes down to here, function comes up, graph like that. And it would do the same thing on any of the periods. And what's going to happen is you're actually going to get a bunch of these pictures with the vertical asymptotes happening as such. Now notice that tangent actually has a different period than sine and cosine, so tangent is quite different. In the way it looks, it also has a different period. So the period of the sine function, notice how we go from negative pi over 2 to pi over 2. That's not doing a complete rotation of the unit circle. It's only doing a half rotation. So for example, pi over 2 is up here, and negative pi over 2 is down here. So going from there to there is only a half rotation of the circle. So tangent actually has a period of 2 pi. Now looking at the properties of tangent, the domain of tangent, in other words, the allowable x values, this is all real numbers except for those vertical asymptotes. Those repeat, so just listing them here. It's impossible to make an entire list because there's infinitely many, but they're happening on every odd multiple of pi over 2. The range, if you'll recall, because the graph goes on forever in the x and y direction, is actually all real numbers. So you can write that as all real numbers. That's the same thing as writing negative infinity up to infinity. And then recall, we talked about that the period of the tangent of function is actually the value pi. If you wanted to graph this in your calculator, well, what you could do, press the y equals button. Here, instead of choosing sine or cosine, we're actually just going to choose tangent. So here in your calculator, delete those, choose tangent of x, close out that parenthesis, hit the graph button. Let's see what that's going to look like. So tangent function looks like that. We might even want to zoom back into a standard window to get a better look. So go back to the 10 by 10 window. And you can get a good picture of what's happening. Now, just as a comment, depending on how your calculator's plot features are drawn, your calculator may be connecting these points here. If it's doing that, it's technically just connecting points as it plots them. So it is up to you to know that that's not actually connecting. What's actually happening here is that there's vertical asymptotes here. And again, notice how in the calculator it's difficult to tell right where the vertical asymptotes are occurring. So your best bet is to get the exact values from the unit circle. Figure out where tangent is undefined. That's where the vertical asymptotes are occurring. Now you can use this basic knowledge to graph variations of the tangent function. So suppose you wanted to graph a shift of the tangent function. Well, remember how shifting goes. If you take a function and add a positive constant, it goes up c units. If you subtract a positive constant, you're actually going down. If you combine x with a positive constant inside of the function, that's actually a left shift in general. And if you subtract from the x value, that's actually a right shift. So what we've done here with a graph of y equals x plus pi over 4 is we've actually indicated that we would like to do a left shift, pi over 4 units. So, graphing this, remember that on the tangent function, previously our vertical asymptotes would have been at pi over 2 and negative pi over 2. But what's happening here is we're actually asked to be shifting left pi over 4 units. Well, shifting left pi over 4 is going to put the new vertical asymptotes at pi over 4. And this one will shift to negative. So again, we're going pi over 4. So this is going to shift to negative 3 pi over 4. And then our new vertical asymptotes are going to be there. Function looks like this. Although this is just one period of the function. Remember, it's going to have repetitions of that in both directions. So y equals tangent of x plus pi over 4 looks like that. And you could take a look at that in the TI calculator if you wanted to. So this time on our y equals menu, instead of doing tangent of x, we're looking at tangent of x plus pi over 4. And press graph. So notice how it's a left shift. It no longer goes through the point 0, 0 because tangent goes through the point 0, 0. Now, in general, it would be helpful for you to have these basic graphs memorized. So for y equals sine of x, just recall that to be able to graph one period of it, it goes up to 2 pi, right? And starts at the origin, looks like that. Now, of course, you can have shifts of this, or stretches or shrinks, but that's the basic graph. The basic graph of y equals cosine of x. Now remember, y equals cosine of x also has a period of 2 pi. But it doesn't start at the point 0, 0. It starts up at the point 1. Looks like this. Lastly, the graph of y equals tangent of x. Now, a period of tangent of x is not 2 pi, it's actually pi. It does go through the point 0, 0, vertical asymptote at pi over 2, and negative pi over 2. So one period of the tangent function looks roughly like this. Thanks for your attention.